So let's look at a few basic postulates and theorems about relationships in circles. And first we want to look at arc addition. So here I have arc MN, there it is on my circle, and I have arc NO. That one's right there. I know the measurements of these two arcs, and then I could use them, since I know them, to find the measurement of arc MNO. All I have to do, since I know MN is 60 and NO is 70, is add 60 plus 70, and that's 130. So my green arc here, MNO, is 130 degrees. Why don't you pause it and try it with the next one? So once again, we add our two arc measures together, and this time we get 150 degrees for the measure of arc PMN. Here's a very useful theorem for you, the inscribed angle theorem. What it says is that the measure of an inscribed angle is equal to half the measure of its intercepted arc. In other words, if my angle measure is x, then my arc is 2x. So let's look at an example. If our angle SAM, is 30, then what would the arc be? Well, 30 times 2 is 60. So our intercepted arc would have 60 degrees. Okay, now what if we changed it up? What if arc SM was 140 degrees? What would the angle measure be? Well, 140 divided by 2 gives us 70 degrees. So just by multiplying or dividing by 2, you can find the measures of intercepted arcs or inscribed angles as long as you have one of them. If you know the angle measure of an inscribed angle, multiply by 2 to find the intercepted arc. If you know the measure of the arc, divide by 2 to find the measure of the inscribed angle. So diameters give us a special case of the inscribed angle theorem to think about. So remember, a diameter goes through the center of the circle and it basically cuts the circle in half. So that means this arc is going to be a semicircle. It has 180 degrees. So if that arc has 180 degrees, what do you think would be the measure of the angle that is subtended by that arc? Well, 180 divided by 2 is 90 degrees. So by the inscribed angle theorem, this should be a 90-degree angle that's intercepting that semicircle. And that's what the inscribed angle of a diameter theorem says. It says that the endpoints of a diameter lie on an inscribed angle if and only if the inscribed angle is a right angle. So to say that in short words, an inscribed angle that has 90 degrees is going to intercept a semicircle. And a diameter is going to connect the endpoints of that inscribed angle.